The next part of this chapter deals with reflecting graphs and stretching graphs. So in the first question we're asked to sketch the graphs of f of 2x and 2 lots of f of x, where f of x is 9 take away x squared. In order to do that, though, we're first going to make a sketch of this graph. You can do that in a couple of ways. You can think of it as the graph of minus x squared plus 9, so minus x squared and have it quadratic, shifted 9 up. Or we should notice it's an example of completing the square. So it's going to be 3 plus x, 3 minus x, so it's going to cut the x-axis at minus 3 and 3, where f of x equals 0. When x equals 0, y, f of x equals 9, so it's going to cut the y-axis at 9. So it's a quick sketch of this graph. It's going to look something like this. 9, 3, minus 3. Now, in A, f of 2x, that's inside the cage, inside the bracket, next to the x of x, the x. Inside the cage is squashed. It's a squash by a factor of 2, or enlargement by a factor of half. So everything gets crushed towards the y-axis by a factor of 2. We divide the x coordinates by 2. So 3 becomes 1.5, minus 3 becomes minus 1.5. This point is unchanged because x equals 0, so half of 0 is still 0. So this graph is going to look very similar. It's just been squashed towards the y-axis. B, 2 lots of f of x. This time we're multiplying by 2, so it's an enlargement. Outside the cage, you're all about the vertical, and this time you're going to stretch by a factor of 2. So these points remain unchanged because it's where y equals 0, so 2 times 0 is still 0. But this 9 is going to jump up to 18 because you're going to double the y coordinates. So this one's going to look similar shape. 3 minus 3, 18. Just be really careful on questions about A and B with 2 types of transformation that you don't transform your answer to part A. It's a very common error. On to example 13. We've got the cubic equation, so let's have a look at what that'll look like as a quick sketch. It's going to go through the x-axis at 0, 2 and minus 1. When x equals, say, 3 or positive infinity, we've got 3, 1, 4, positive, positive, positive. If it's positive, it's going to go off to heaven. So it's a quick sketch. 2, 0, minus 1. Now, we're not told what to sketch in terms of f of x this time, but what we can notice is, here's the original equation, and what's changed in part A is that x has changed to 2x every time. So f of x has changed to f of 2x. So it's going to be a squash by a factor of 2 again. So the 2 is going to divide by 2 is 1. Minus 1 divided by 2 is 0.5, minus 0.5. It's still going to go through the origin. Okay, B. So this time, what's happened to our original equation? Well, the x has changed to minus x, but the other 2 brackets remain unchanged. So the x hasn't changed. What happened is the f of x has changed to minus f of x. And this is an example of reflection. It's outside the cage, so it's all about the vertical. So we're going to be reflecting vertically, or reflecting through the x-axis. So it's just going to turn it upside down. Not this one, this one. I mean, you can say it's an enlargement by a factor of minus 1, but effectively it is a reflection. Let's go through the origin. On to the last one, example 14. We've got the original graph, which is going to be a quadratic, going through the x-axis at 0, minus 2. It's looking something like that. We don't know if we need the turning point, but if we did, it would be at minus 1, and when x is minus 1, you'll have minus 1 times minus 1 1, which would be -1. And in part A, we've got the negative, so it's a reflection. Next to the x of x, the x inside the cage all about the horizontal. So that's a horizontal reflection. So you're just going to flip it that way. B, outside the bracket, it's going to be a vertical reflection, reflecting through, turn upside down through the x-axis. So A is going to look simply like this. And that point there would change to 1 minus 1. B, just turn it upside down. So -1, 1. Okay, that's all the examples prior to exercise 4F.